Okay, we're back to this thing here, which was from the previous video about the SN7, well not the SN, but the 74HC595. So the SN actually just refers to Texas Instruments, so that letter will change depending on the manufacturer. So anyway, if you recall, it is a serial shifter thingy chip, a serial to parallel converter. Sorry, this desk is very cluttered today. But anyway, so last time I'd only done 4 things and I hadn't quite got it working. But now it's kind of working, so we're just going to add a few extra features just for the fun of it and talk about a small issue and see if we can find a solution. So let's just turn it on, and so this thing here is flashing to show the clock rate. So this is coming from one of these little tiny 555 timer boards. I actually got some more of these in the mail today. I went and bought a whole bunch of them. So these are the simpler version of those things, and so they just got one little thing to adjust, and that just adjusts the speed. This one here is a little bit more comprehensive. We will go into 555 timers at some point, but I'm not in any rush because there's a lot of things about them on the internet. But anyway, they're handy to make a little clock thing. So this does kind of work. At the moment though, we have to take the wire out and move that over to there. And now we're on to the positive rail. So what's happening here, it's this wire, this big wire here is feeding into the serial input. So when I move it from the high voltage to the low voltage, it now goes low, and so it's shifting in low bits, and then I can actually add in a couple. So if I move it around or not, okay, it's a bit delayed, isn't it? Now it's going all strange. Oh, I know why. Sorry. So the trick about that little thing there is I in fact had to link 2 of these little boards together, so 2 of these together, because I ran out of room, and so I've only linked up the negative rail on this side here. So there's a little tiny wire just here that's linking that up. So when I moved it over to here, it's not actually connected to anything, so it's just picking up some sort of fluctuations. It's not going to do the same thing it did a minute ago, which is a shame. Oh, there we go. There we go. It's a bit random now, so you've got some random sequence, kind of, almost. But what I want to do is add in a few little buttons and make it slightly more interesting. And this is going to lead on to a few more videos, I'm afraid. I'm going to be quite good at making a few videos out of what seem like a very trivial task. But the first thing we'll do is we'll just do the 1 button version. So remembering, we're going to have to talk about pull-ups and push-downs and all that kind of pull-up and pull-down resistors. So I'm going to do it on another board because I'm just running out of room. But that's the good thing about these, is that we can just shift these onto here. So now I'm linking that one up, and we're going to need more wires. And I've got the funny feeling I wasn't actually as prepared as I thought because I haven't got all my wires ready. There, well, I've only got these wires. That's funny, because I had a box of these, a box of brand new ones, just for this purpose. Give me a second. No, I really have not prepared for this. I've taken away all my little wires. That's alright, there's enough sitting on the desk to not worry. We'll get one of those. We don't need that many actually, so I've got enough. What I do need, so what we'll first do is I have to link across. So what we'll do is we'll make, by default, it will feed in a low voltage, so it will go dark. And when we press the button, it will pull it up to be a high voltage, which is pretty straightforward, I think. What have I done wrong? I've completely done this very strangely. Hold on, I want that one to go to there. So I am not going to do that. Alright, so which one is the input? So the input we're going to bring over to here for a second. So this is the input wire. It's going into the serial input on the IC. So that is probably this one here, pin 14, serial input. That's what it's feeding in. and we're going to need a resistor. So this is a packet of resistors. So I'm going to try and use this little packet of components that all came together. It's like a cheap little pack, and so I'm kind of wanting to use most of the same thing. I didn't use the same resistors, but you can pick them out of here. So they came with a pack of these. I think these all are like starting with 10 and going upwards. See if I can pick out the one that I want. Well, that one looks pretty high. So that's a 1. I don't know if you can see this. We'll just practice doing this. It actually came with these little charts, which is quite handy. So this chart here tells you how to read the numbers on the side. And so this one here is brown. It's always a bit tricky because I can read them both ways. But in general, well, actually this one might be that way, won't it? Oh, that's a bit confusing. So this is possibly going to be brown, black, black, red, which would be 1, 0, 0, followed by 2 more zeros, because that's red. What red is 2, and so it goes. You read the numbers, and then the last one is just how many extra zeros you want to add onto it. Essentially, because you could actually take away zeros if it's got gold on the end. So if it's like a 10 ohm one, you'll actually see a gold if it's got 4 bands. But I believe this is probably a 10,000 ohm resistor, and I'm just going to, which is kind of what I want. Yeah, 10,000 ohm. That sounds like a good value for a pull down resistor. So if you remember from the last one, it seemed to work fine. So I'm going to get out my multimeter, and I'm just going to test that because I want to make sure that I got that right. And no, I had the funny feeling it was going to be that way. It's the other way around. So we're reading it from this side. So it's red, red, black, black, which is going to be 2200. No, it's not. It's going to be 220. This is nowhere near what we want. So that's what I hate about these things, is that you have to read them 2 different ways. So in that case, that one's definitely a 100 because that's brown, black, 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 brown. So we can kind of guess that the last one is the tolerance, which is brown. So this is also 222. That's where I pulled that one from. All right. I should have prepared. Yeah, should have. Well, this one looks good. This one's got orange, orange. No, that's still this. That's a 3300. Boring. Here we go. Here we go. So I'm pretty sure this one is brown, brown. Okay. Actually, I want brown, brown, red. Brown, sorry, I want brown, black, black, red. How hard can that be? Well, I want red in there somewhere. Well, this one looks kind of encouraging. Oh, here we go. This one's the one we want. If you're lucky, they write them on the side. The best thing to do is to go through and work them out and then write them on the label so that you don't have to do this every time. And that one is 10. There we go. That one's 10k. So it's been a big mess on the desk. And it was no good at all. So we're going to get this one, and this one is going to go to here. So as soon as I link this positive, actually we can't quite reach. Alright. So the trick here to remember, so I'm having a 10k resistor, it's going into here and into the input, but nothing is happening at the moment because this is not actually linked up to the power rail, so I'm going to have to add a little extra link in messy style, and I'm going to use this thing here, and it's just going to go over like that. So as soon as I do that, it should all go red. And then we're going to do a pull-up trick. So right now, that's a bit odd. No, I want to pull it down. That's what I wanted to do. I want to pull it down to, I want it to go blank. So now I'm pulling it down. What kind of wire am I looking for? This one will do. And then I'm going to add in this to the button, and because I can't be bothered adjusting the wire, and I kind of want a nice looking wire, I'm actually going to move the button. So the button can go here. So now I'm adding in this. So this thing is connected to the positive rail, in a very stretched way. Actually, let me just move it along a little bit. Okay. So now when I press the button, I will be making a direct connection to the positive rail. So this is pulling it down to... Oh man, can't have it looking like that. Alright. Now I got the wrong colour wire. So when I press the button, so when these little things, that's just interference. When I unplug the wire. When I press down the button, it should start going red. And it is. And then when I let go, it should stop going red. There's a bit of delay, and we're going to talk about that a bit later on. But we'll come back to that in a second. So the thing that I really want it to do, so the ultimate thing is I want to have two buttons. One turns something off and one turns something on. But the pattern, I want to continually go round in a circle. So how do we do the round in the circle bit? The other problem is that there is that strange delay from me pressing and holding the button to when it actually shows up. And we're going to talk about that. I briefly mentioned the problem was using, so there are two clocks. One of them is the latch clock, which shifts all the internal value up to the outputs, which we're doing every single time we also do a shift clock. And because there's a kind of weird little conflict with that, and that it does the shifting after it does the latching, you kind of get this 1 frame delay. But we'll come back to that. But what we're going to do here is look at the last feature on this thing here, which is the carry output. So when the H1 comes out, these inputs are labeled in letters. So we've got A, B, C, D, E, F, G, H, and then H dash. Actually, I'm not entirely sure what H dash, why it's that. Well, that's what happens to H when it goes out. So this is like the 9th bit. But we want to take this one and we want to put it back into the first bit. And well, I'm not entirely sure how this is going to work straight off if I'm going to have this little button here. But we'll try it. So, what's the first thing I should do? Which is 8. This is pin number 9. So let's just find it on here. Oh, it's very easy to find. It's down the bottom. So I'm going to take that wire and put that into the pin number 9, which is down here. And then I'm going to feed this into the serial input, which is actually this pin here. So I'm going to just for fun, I'm just going to put it straight over here and see what happens. And then I'm going to press the button and see if that makes any difference. Alright, that's going to come on. And let's just see. Oh, I don't think it's going to work. It might. Hey, it did work. So there you go. We probably don't need that anymore. So now it is feeding into the input what goes out the end. So as soon as this one goes out the end, it's going to go popping into there. So I guess there's a little bit of syncing issues, because you've got to worry about the time when these things like change and then when it reads it essentially. And so I think that's what the H dash is for. I was going to look that up when I come back. What happens if we put it straight onto H? That's what I want to see. So there's a QH and a QH dash. So I'm going to try it on 7 and see what happens if I do that. It probably goes all funny. It doesn't work at all. Oh no, it does kind of work. No, it's going all odd. So 3. Oh, that kind of works too. Oh, well, it looks very odd now. Okay, I'm going to come back to that because I'm kind of a bit like, I don't think that worked. It works better that way, doesn't it? Well, there's no confusing jumps around. Yeah, okay. Alright, we'll stick with that. There's not them. That doesn't look right. 1, 2, 3. Oh no, that's fine. Okay, anyway, you get the idea. But now we're just going to have 2 little buttons. And so in this case here, just to finish this off, and I drew a little picture. How much time have we got? got a good amount of time. Let's keep this short because we've still got another issue to talk about on this whole thing, which is going to turn out to be quite a little fun detour into weirdness. So this is my idea. So here's my 10K. So this is going to be not a pull up or a pull down. It's just pull whatever way it's supposed to be. So the serial out, which is QH dash, is going to go through here, and it's going to have this resistor in the way. So this is going to be weakly pulled to whatever the serial out is. So the serial in is going to be weakly pulled to either of these things, and then when we press the button, all we're going to do is we're going to strongly pull them to 0 or 5. So we're going to essentially override this. So this is a pull some way resistor. It's not a pull up or a pull down. It depends on what's coming out of here. So this was a low voltage, it becomes kind of like a pull down resistor, and that's a high voltage, that's a pull up resistor. So let's just quickly see if that works, and maybe we'll just finish there and come back for the next one next time. And we're going to get around to doing Pong again, don't worry, because I've got so many things I really want to get into. So let's just put a button in. I'm going to need, to make this easier, I will chuck in, I feel like that's the wrong colour. Do I have a long blue one? I'm just getting these things out. So we're gonna fix this up for a second. I'm gonna turn it off just briefly, and that one is going. So the problem is that I now have the option at the moment of making them all on, but nothing else. So if I turn it back on again, this is just a random thing that's inside the. Oh, it's gone all funny. Let's just see if it stays the correct way. 2 in, out. Alright. So now I can make them all on. Like this. But, well, I can't do anything else. I can't turn them off. So once they're all on, you're kind of stuffed. I'm a bit worried about this thing here. I think I'm doing this a bit wrong. But that's okay. I don't think it likes having that low a resistance. But they can almost guarantee it. So I'm going to stick a much lower resistance over there. Doesn't actually matter. The little LED in the corner doesn't actually matter. So it's just there for me to see that it's working. Alright, so now what do we do? So we've got, where did I put that resistor? Well, that was very short-lived. Okay, so that went into there. That went into there. Did I just pull it off? No, that was that one. Alright, well, we'll just get out another one. Oh, here it is. Here it is. So this wire, this blue wire, very helpfully, is the serial output, the parallel output. Now it's just reading random data, and you can't actually see the LED flashing, so that was way too high, but that's okay. And we're going to now put it in with, I'm sure I've done this, haven't I? Where is the other resistor gone? That is it. Okay, so that's going into there, and so it's going through there, and so it should start rotating again. It's rotating again, going through the pattern. And now we don't need this wire here because we've now linked up the two power rails, so we can use the much simpler and more neat and tidy version. So this one's going to be the on button. So that one I'm linking up to the high voltage rail, the positive rail, and then we're going to have also linked to the same one. So remember, this wire is the input, so the serial input, and this one is going to be looking a bit messy, but that's okay, going to the negative rail. So when I press that button, I'm going to be able to turn them off, and when I press this button, it's going to be turned on. And I think what we ought to do, I say that not knowing where I put my little tiny screwdriver, which was just here. I need to find it. It's really important. Hold on. Let me just tidy up very briefly. Oh, here it is. It's literally right in front of me. So if I adjust these things, then we can kind of make it go a bit faster, because it doesn't look very exciting. at this rate. So right now I'm adjusting the clock. I hope. Now it's going slower, so that was the wrong way to go. Alright. Nope, and now it stopped. Alright, well, we'll keep it slow and then we'll move this. But that's kind of prettier. There we go, that's nice. So now it's going along, and I think we've actually done it. So now we can actually play around. It's going faster, so this button is going to go to the high voltage. It's nice and orange, you've got the colors right here. And that one's blue, is going down to the low voltage, and by default it's got this resistor in the way, the pull either way resistor that's going to the serial output. So let's just clear it for a second, and it's gone clear, and then we can turn it on and then off, and on and off and on and off. It's going a bit too fast actually because it can't really do much. So let's see if we can do one little LED, and then I can try and get 2 LEDs, or they're mixed together now, 3, and then you make neat little patterns, and then you can go all on, all off, all on, all off, all on, all off, all on. We do need something in the way. Because there's a problem with this that you might be able to see. And so the best way to sort that out is just to get some resistor that's not too high. So I'm going to get this little 100 ohm resistor, and I'm going to go, so the only thing that I'm worried about in this thing here, the way it is that what if I hold down both buttons at the same time? What I'm actually going to do is create a direct path between, so if you can't see that, if you hold down both the buttons, then there'll be a direct path between the high voltage and the low voltage, which would not be a good thing. So I'm just going to put in a rather low, but good enough for now, not the best solution, but there's a 100 ohm resistor now. So this thing will still pull it down to 0, because 100 is much lower than 10k. But when I hold them together, it's a bit of a strain. Like you can see it, I don't know if you can see there, but the light does fade a little bit. So that's not the best choice of resistor, but it's better than nothing. And so now you've got a little bit of flexible, it's a bit of safety feature, because somebody, if you gave this little toy as a toy to somebody, they're bound to hold both the buttons down at the same time. And you can see that it actually goes high, which makes sense because the high voltage is going straight in, but there's a 100 ohm resistor going from the low voltage, so that's why it overrides and you get the high thing. So I hope that was kind of interesting. We're going to come back. It's not much of an issue when it's going this fast, but when it was going much slower, so we'll zoom it down to like slow mode. If I hold down this button, it's going to do it straight away. So I'm holding down that. There's just a one shift delay. So I'm going to come back and talk about that video, talk about how to fix that, and it's going to go in an interesting tangent, I hope. So anyway, thanks for watching. Like, share and subscribe, and we will be getting on to other things and new ICs and new bits and pieces. So I'm going to put this away properly. Thanks for watching, and bye.